Today we are solving LeetCode 3548, equal sum grid partition 2. What are we actually doing? We are given a grid of numbers. We need to split it into two non-empty parts such that both parts have equal sum. We are allowed to remove at most one cell, and both parts must remain connected. Instead of handling horizontal and vertical cuts separately, we rotate the grid 4 times and always process it as a horizontal split. Now the core idea. We iterate row by row and keep adding values to a running sum. In words, sum increases by each grid value we visit. This running sum represents the upper part. At any point, upper sum is sum, lower sum is total minus sum. To make both equal, we compute a required value. X equals 2 times sum minus total. Because if we remove x from the upper part, sum minus x becomes equal to total minus sum. Now we check if this value exists in the upper part. For fast lookup, we use a hash set. Each visited value is stored so we can check in constant time. If x exists, we return true. To handle vertical splits, we rotate the grid by 90 degrees and repeat the same process. This way, we reuse the same logic and cover all 4 directions. Why these steps? Rotation helps avoid separate logic for vertical cases. The equation gives the exact value needed to balance both parts. The hash set allows fast lookup. The running sum avoids recomputing values again and again. Pattern to recognize. Rotation of matrix. Hash set for existence check. Prefix accumulation over grid. Signals in problems like this. Equal partition with optional deletion means derive a required value. Need fast lookup means use a hash set. Grid symmetry suggests rotation. Repeated sum calculation suggests prefix accumulation. Example, grid is 1, 4, 2, 3. After the first row, upper sum is 5, lower sum is 5. Both parts are already equal, so the answer is true. See you in the next one.